Welcome back to the Foundry by Forge College. So, in our last explainer, we really nailed down the nuts and bolts of real-time analysis and alerting, right? We got those KPI datasets flowing and set up some honestly pretty sweet sliding window aggregations. But there's a catch. Alerts, by their very nature, still need you to physically do something. Today, we're fixing that. We're going to transition from that exhausting, soul-crushing routine of manual 3 a.m. Solana node monitoring to building a highly reliable, fully automated mechanical assistant.
All right, here is our blueprint for today. First, we're going from passive to active. Then, we'll look at the tiers of automation, run through the automation decision matrix, and break down a 5-step workflow. Finally, we'll tie it all together with a real-world RPC pool example and wrap things up with some next steps. Let's get into it.
Okay, let's dive into this. Section 1, from passive to active. Or, as I like to call it, escaping those dreadful 3 a.m. alerts.
Look, we have literally all been there, right? Staring blankly at dashboards, your eyes glazing over, or worse, getting violently woken up at 2 in the morning because your phone is absolutely screaming that a node needs a restart. It's just painful. Well, active automation is a real game changer here. By hooking up our monitoring tools to real-time analysis, we can create these adaptive baselines and programmatic responses. Basically, your systems literally start fixing themselves. You actually get to stay asleep while the machine does the heavy lifting. This drastically cuts down your mean time to detection and feeds those corrective actions directly back into your pipelines.
Moving right along to Section 2, the tiers of automation. Let's build this machine from the ground up.
So, you can think of automation as being built across 4 stacked tiers. Step 1 is observe. This is just passively collecting your metrics into a time series store. Easy enough. Step 2 is detect, where we use rules to flag any deviations from the norm. Step 3 is orchestrate. This is where it gets really fun, translating those detections into actual coordinated responses, like scaling nodes. And the very top tier, Step 4, is remediate, which is executing closed-loop, safe actions. Now, to be clear, we aren't just letting some script run wild. We're building a highly logical, mechanical assistant that makes practical trade-offs between risk, speed, and human oversight at every single tier.
Next up, Section 3, the automation decision matrix. This is our if this, then that mental model.
So a big question you might be wondering is, how do we actually decide what to automate without, causing absolute terror? Imagine an automated ledger pruning script just going rogue on a live deployment. Yeah, no thank you. To keep our system safe, we evaluate every single alert against 3 critical attributes. Number 1, impact. Like, how much does this actually affect the user experience or the protocol's integrity? Number 2, repeatability. Does this condition happen in a predictable way? And number 3, which is absolutely crucial, reversibility. Can this action be safely undone without causing some massive cascading failure? Take a Solana transaction latency spike, for example. That's a classic case of high impact and high repeatability.
And those 3 attributes feed directly into this brilliant, simple checklist. If an issue is high impact, high repeatability, and highly reversible, boom, automated immediately. But what if it's high impact with low reversibility? Well, that's too risky, so it requires a manual review or a canary deployment to keep things safe. And if it's low impact and low repeatability, just monitor it. Seriously, don't waste your time engineering a complex robot for a problem that barely affects anyone and almost never happens.
Now, as you're designing these automated responses, you are definitely going to hear the term idempotent action tossed around a lot. What does that actually mean? Well, an idempotent action is simply one that can be repeated multiple times without compounding side effects. Think of it kind of like impatiently mashing an elevator button a dozen times. Pressing it over and over doesn't magically spawn 12 elevators, right? And it doesn't crash the building's power grid. It just safely registers the command to do the thing once. And that is exactly the kind of safety net we want built into our automation.
All right, Section 4, the 5-step workflow, going from metrics all the way to an automated response.
If you've taken any other courses with us here at Forge College, you already know we absolutely love repeatable workflows. And this continuous closed loop, this is true automation. Step 1, you collect your KPI time series and make sure they're tagged properly. Step 2, detect those anomalies using your rule engines. Step 3, decide. This is where you add context to the anomaly so you can figure out the correct response path. Step 4, act, meaning you execute the response cleanly. And finally, Step 5, which is arguably the most important of the whole bunch, verify.
Let's break this down a bit more so you can see the specific output of each component. Your collector gives you tagged time series data. The detector spits out an alert that's tagged with a specific severity level.
The router takes that severity and maps it directly to a playbook. Then, your action engine actually executes the API call. And finally, the verifier steps in to check the post-action metrics, confirming the system actually recovered. Guys, I literally cannot emphasize this enough. Automation without that final verification step just compounds your risk. Small errors evolve incredibly fast in high-throughput environments like Solana, so you absolutely must verify.
Okay, Section 5, Real-World RPC Pool Example. Let's look at automating latency remediation. Now, what's really interesting here is how we apply all this abstract theory to a concrete scenario. Imagine your production RPC pool is showing this sustained increase in average transaction latency. We start with step A, which is detection refinement. Obviously, we don't want to trigger some massive scaling event the very millisecond things slow down. Instead, we set a trigger where the 5-minute median latency has to exceed 200 milliseconds across consecutive windows. That right there prevents those noisy, short spike triggers from firing off your automation prematurely.
But we want to be absolutely 100% sure, so we combine that latency signal with an RPC queue depth of over 50. By requiring both conditions, so high latency plus a backed up queue, we can confidently confirm the system is genuinely struggling before we do anything about it.
Next up are steps B and C, where we map out our decision routing. Let's say it's a medium severity issue. That might just drop a quick notification into your team chat with a one-click semi-automated playbook approval. But what if it's a critical severity? Well, that bypasses the chat entirely and triggers a fully automated API scaling action to immediately add RPC workers. And because we mapped our routing perfectly, the action is exactly matched to the severity level, utilizing those safe, idempotent API calls we defined a minute ago.
And then comes the absolutely critical step D, verification. After the system scales, it automatically measures the KPIs for a 10-minute window. We have to ask, did the latency actually improve by the agreed margin? If it did, fantastic, we record the success and move on. If not, the automation marks the attempt as a failure, escalates it to the on-call engineer, and records all the diagnostics. We use every single one of these incidents to continuously learn and tune our thresholds.
It boils down to this: treat automation like a feature that must be tested and monitored. If your automation fails silently, you entirely lose the protection you worked so hard to build. It has to be measurable, and it has to be improvable. No exceptions.
Finally, Section 6, Conclusion and Next Steps. Getting prepared for deployment pipelines.
All right, it is time to wrap up today's blueprint so we can set the stage for our next lesson on integrated deployment frameworks. Just to summarize what we covered, always prioritize your automation candidates by impact, repeatability, and reversibility. Second, instrument every single automated action with verification. Third, treat your automation just like software. Deploy it incrementally and test it in staging with realistic traffic. And for your homework, your next step, I want you to draft a short automation plan using just one high-impact KPI from your existing datasets. So ask yourself right now, what high-impact, highly reversible KPI will you automate today so you can finally sleep through the night? Think about that as you sketch out your plan, because that artifact is going to be the foundation for our next lesson. Thank you so much for joining me for this explainer. Be sure to visit forge.college to explore more Web3 resources, dive deeper into Solana deployments, and check out more of our courses. Until next time, keep building and keep automating.